Welcome students, let me continue our next class, that is on limits and continuity. Let me continue the exercise 12.1, 13th example you see here. See, this is a problem based on trigonometric function and we need to use the standard limits what we have studied in this topic. With respect to trigonometric relation, you have studied this relation, limit theta tends to 0, sin theta upon theta. This is equal to 1 here. Even the same result can be applied if it is in this manner. Limit theta tends to 0, theta upon sin theta. This is also equal to 1 here. And one more result remember, limit theta tends to 0, tan theta upon theta, that is also equal to 1 here. This is also equal to 1. But don't think so, sec theta upon theta is 1, cot theta upon theta is 1, not like that. Tan theta upon theta is equal to 1 here. Basically, we are using these two mainly. Limit theta tends to 0, sin theta upon theta equal to 1. And limit theta tends to 0, theta upon tan theta, theta upon sin theta equal to what? 1 here. Okay, let us solve the given problem here. See, in the given problem, limit x tends to 0 is there. Limit x tends to 0, sin ax divided by bx. This is the given problem here. Okay. See, I would like to split the term in this manner. Limit x tends to 0. Let me write 1 by b separately because it is not having any link with that angle here. Sin ax you write. See, divided by only x is there, but instead of x I would like to write ax. So a is an extra term what you have taken. In order to adjust it, you multiply by a. You multiply this one by a here. Here only I would like to take. So in the next step of calculation, this constant a and this constant b, that means as a whole a upon b you take outside. By taking a upon b outside, under the limit what remains, limit x tends to 0, sin ax divided by ax, sin ax divided by ax. This is the standard limit. See, this is equal to a upon b into sin limit theta tends to 0, sin theta upon theta is equal to what here? 1 you know already. So based on that you can write it as 1. So the answer is a by b. But there may be a slight confusion if you think very seriously. Sir, theta is tending to 0. Please concentrate, try to understand here. This theta, this one and this one, these three must be same. But see, this ax is same with this ax, but there is a slight difference here. X tends to 0. It is customary how you see here. X is tending to 0 means if you multiply by a into x tends to a into 0. That means ax is tending to 0 now. So instead of x tends to 0, you can write ax tends to 0, no problem here. But no need to write it again. Just you visualize in your mind and then apply the result. That's all. So this is the theme behind this here. Now let me continue the next example. Let us take into consideration the next example. Again, this is also based on the same property. Limit x tends to 0, I would like to write. Limit x tends to 0, sin ax divided by sin bx. Sin ax divided by sin bx here. See, this is equal to limit x tends to 0, limit x tends to 0. I would like to write like this, sin ax divided by ax I would like to write. See what I have taken extra, ax I have taken. See how I will adjust it. Sin bx is there, sin bx is there. For my conveniency I would like to divide it by bx. So naturally in the mode of simplification this x and x will cancel, definitely. So no need to adjust that x. Only you need to adjust this a here. Extra term what you have taken, a you have taken, into a, right? Here into b you write, b is taken extra. So a upon b you can be a upon b can be taken outside, a upon b, and then remains what? Limit x tends to 0, limit x tends to 0, sin ax upon ax, sin ax upon ax whole divided by sin bx upon bx. So this is what the situation where you need to apply the rule of the limit. This limit x tends to 0 is to be applied to both numerator as well as denominator. So this is equal to a upon b into limit x tends to 0. What we can write? Sin ax divided by bx, sin ax divided by ax whole divided by see a upon b is taken outside and limit is splitted here to both numerator and denominator. This is sin bx upon bx, sin bx upon bx here. Now this is a standard limit, a upon b you write as it is. So numerator is also 1, denominator is also 1, both are in the standard form. Limit theta tends to 0, sin theta upon theta. Ax again same case. In the previous case what I told, same link is there here again. So a upon b into 1 upon 1 is leading to the answer a upon b. So the answer for this is a divided by b. I hope you followed. If you have any doubt, you please tell me in the first example as well as in the second example. I have applied limit theta tends to 0, sin theta upon theta equal to 1 in both the cases. Is it clear for you all?
Yes, sir.
Okay, then continue the next example. Limit x tends to pi, sin of pi minus x, sin of pi minus x divided by pi into bracket pi minus x here. Okay. Now, let me take into consideration 1 by pi constant which is outside. You take it outside. Limit x tends to pi you write. Then sin of pi minus x divided by pi minus x. See a little bit some substitution you need to make here. What's that? You put pi minus x is equal to theta. Pi minus x is equal to theta. So when you substitute pi minus x is equal to theta, then limit also changes. When x tends to pi, then look here carefully, x is approaching to pi. But for the calculation purpose, in the substitution pi minus x, you substitute x equal to pi. Then this is theta is tending toward here 0. That's what x equal to, you need to substitute pi here, pi minus pi, which is equal to what here? 0. So pi minus pi is 0 on left side, right side theta is there here. So theta equal to what you are getting? 0 you are getting. That itself is the new limit, theta tends to 0 here. So make these changes here. Take 1 by pi, 1 upon pi you write as it is, into limit, don't write x tends to pi. You write the new limit theta tends to 0. This is the new limit. Then don't write pi minus x, needs to write theta whole divided by theta. Now clearly it is in the standard form and its answer is 1. So 1 by pi into 1, which is equal to 1 upon pi. This is the answer for this question. In this substitution and the change in the limit, is there any doubt? ಇದು ಅರ್ಥ ಆಗಿದೆಯಲ್ಲ ನಿಮ್ಗೆ? ಪೈ ಮೈನಸ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಥೀಟಾ ತಗೊಂಡೆ, ಆವಾಗ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು ಪೈ ಓಲ್ಡ್ ಲಿಮಿಟ್ ಇತ್ತು, ಹೊಸ ಲಿಮಿಟು ಥೀಟಾ ಟೆನ್ಸ್ ಟು 0 ಯಾಕಾಯಿತು ಅನ್ನೋದು ಅರ್ಥ ಆಗಬೇಕು. ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು ಪೈ ಅಂದರೆ ಅಲ್ಲಿ ಪೈ ಮೈನಸ್ ಎಕ್ಸ್ ಐತಲ್ಲ, ಅಲ್ಲಿ ಪೈ ತುಂಬ್ಕೋಬೇಕು. ಪೈ ಮೈನಸ್ ಪೈ 0 ಆಗ್ತದೆ ಅಂದರೆ ಥೀಟಾ ಈಕ್ವಲ್ ಟು 0. ಸೊ ಥೀಟಾ ಟೆನ್ಸ್ ಟು 0. ಅರ್ಥ ಆಯ್ತಾ? ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಹೊಸದು ಇಲ್ಲಿ ಬಂದಿದ್ದು. ಮಾತಾಡಲೇ ಇಲ್ಲ ಯಾರು?
Yes, sir. Yes, sir.
Okay. Then next question, limit x tends to 0. X tends to 0. Cos x divided by pi minus x. Pi minus x. Direct evaluation is possible here. Cos 0 divided by pi minus 0 here. Cos 0 is 1 divided by pi minus 0 is only pi. So the answer is 1 by pi for this question here. Now next question, somewhat interesting. Please observe here, somewhat lengthy also here. Limit x tends to 0, cos 2x minus 1, cos 2x minus 1 divided by cos x minus 1 is there here. Cos x minus 1 is there. See, for cos 2x there are three results. In trigonometry we have studied. All those results I would like to recall. Cos 2x is equal to cos square x minus sin square x 1. And another one is 2 cos square x minus 1. 2 cos square x minus 1. And another result for cos 2x is 1 minus 2 sin square x. Please concentrate here. Cos 2x is involved. Cos x minus 1 is there in the denominator. So it is better to use the first result. If you use the first one, minus 1 you take to this side. No. 1 cos 2x minus 1 is there. No, second one you use. So this is cos 2x minus 1 is equal to minus 2 sin square x you will be getting. Minus 2 sin square x. Cos 2x minus 1 is minus 2 sin square x. According to me that is not convenient. Let me check the one nimisha. See, in this case 2 cos square x minus 1, first result itself you use. See what happens. This is equal to limit x tends to 0 you write as it is. Cos 2x is equal to 2 cos square x. 2 cos square x minus 1. Minus 1 is already there. One more minus 1 that you need to write. See, cos 2x formula is 2 cos square x minus 1. And denominator you write as it is. Cos x minus 1 here. Now this is limit x tends to 0. Limit x tends to 0. 2 cos square x you write as it is. 2 cos square x minus 1 minus 1. That leads to how much here? Minus 2 divided by cos x minus 1. Cos x minus 1. 2 you take common. This is equal to limit x tends to 0. Limit x tends to 0. By taking 2 common, this remains cos square x minus 1 remains divided by cos x minus 1 here. Now cos square x minus 1 can be thought of cos square x minus 1 square, that is a square minus b square. So a plus b into a minus b formula apply here. So this becomes limit x tends to 0. Please concentrate here. 2 outside you write as it is. 2 bracket cos square x minus 1 square. A square minus b square. A plus b cos x plus 1. A minus b cos x minus 1 here. This is one thing divided by cos x minus 1 here. This is cos x minus 1. Now what happens? Cos x minus 1 cancels. Limit x tends to 0. Limit x tends to 0. 2 into bracket cos x plus 1 here. Cos x plus 1. Cos x minus 1 eliminates. Now it is the time to evaluate. X tends to 0. 2 outside you write as it is. Cos x, that means x equal to 0. Write cos 0. Direct substitution here in this case. Plus 1 as it is. No change in it because it is a constant. So cos 0 value is 1. 1 plus 1 is 2. 2 into 2 is 4. So the final answer for this question is 4. So this is what the solution for this example. ಅರ್ಥ ಆಯಿತು? ಏನಾದರೂ ಡೌಟ್ ಐತಿ ಇಲ್ಲಿ? ಆನ್ಸರ್ 4 ಇದೆ, ಕರೆಕ್ಟ್ ಇದೆ. ನೋಡ್ಕೊಡ್ರಿ, ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Now let me continue the next example. That is what you know, limit x tends to 0. ax plus x cos x divided by b sin x. This is the given problem. If you observe the problem carefully, in the numerator it is found that x is common and that can be taken outside. Do that. Let us see what happens. Limit x tends to 0. Take x common, remains what? A plus cos x remains. Divided by, see, b sin x is there here. B sin x. I would like to write this is equal to limit x tends to 0. 1 by b separately I would like to write a plus cos x in the numerator divided by sin x divided by x I would like to write. In the mode of simplification it goes to the numerator again. It will be tallied here. Okay. Now you apply the limit. 1 by b you take outside. Taking 1 by b outside. Limit x tends to 0. To numerator you apply a plus cos x. A plus cos x. This is the numerator term. And for the denominator term you apply the limit. X tends to 0, sin x upon x. Limit x tends to 0. This is sin x divided by x here. So what happens? 1 by b outside, 1 upon b outside as it is, into numerator is a plus cos 0, x equal to 0 you substitute here, it will not take 0 by 0. Denominator is a standard limit, its value is 1. So this is a plus 1 whole divided by b. Cos 0 value is 1. So a plus 1 into 1 is a plus 1 only. B into 1 is b. That I have written. So this is what the answer for this question. Let us move to the next question. See direct evaluation. Limit x tends to 0, x tends to 0, x into sec x. Because this is equal to 0 into sec 0. Sec 0 value is 1. 0 into 1 is definitely finite value. 0 we will get here. So 0 is the answer for this question. Now let us move to the next question. Little bit lengthy. Please concentrate here. This is equal to, this is a limit x tends to 0, sin ax plus bx whole divided by ax plus sin bx. Ax plus sin bx, that I would like to write it as sin bx plus ax. Just rearrange the terms, exchange the terms. Now this is equal to, just observe the steps. Limit x tends to 0. Sin ax, I would like to write it as sin ax divided by ax. What extra I have taken? See, ax is taken extra, multiply by ax. Plus bx is there, write bx front, divided by sin bx is there, write sin bx, divide this one by bx. Okay. In order to tally this, you multiply by bx. And then what to write? Plus ax you have to write. Plus ax. Okay. Now, limit x tends to 0 is there outside. It is applicable to both numerator as well as denominator here. Okay. Now this is equal to, this is equal to limit x tends to 0, limit x tends to 0, numerator you see here, sin ax divided by ax into ax plus bx. In this case, what we can take common? X we can take common. X you can take common here. Ax plus bx is there, no? In the next step, I would like to take, keep it. Otherwise, you do here only. X you take outside. By taking x, this limit, and this becomes sin ax divided by ax. Take completely outside. Into a remains here. Plus b remains. I have taken x from both the terms of the numerator. Similarly, in the denominator also, you do one thing, x you take common. Then this becomes sin bx divided by bx as it is. Out of that bx, x is taken outside, into b remains, plus x is taken outside, a remains. Somewhat tricky, please concentrate here. If you have any doubt at this stage, you please tell me. From both numerator and denominator, I have taken x common. And at this stage, it is the time to eliminate x from both numerator and denominator. And now you apply the limit to both numerator and denominator. By applying the limit to both numerator and denominator, see what happens. Limit x tends to 0 is there in the bracket. Sin ax upon ax into a. Sin ax upon ax into a plus b whole divided by limit x tends to 0. Limit x tends to 0. Sin bx divided by bx into what's that? B plus a. B you write and then plus a. Please concentrate. You apply the limit to both the terms. It is a constant here. Okay, rules of limits. Recall that. Limit x tends to 0. Sin ax divided by ax as it is. This a constant you write outside plus limit x tends to 0 b. X tends to 0 b whole divided by, take this b constant outside, limit x tends to 0 sin bx divided by bx here, sin bx upon bx. See, b is taken outside. Apply the limit to the next term. Limit x tends to 0. What is there? A is there here. Now this is a standard limit. This one is also a standard limit. A into 1 plus limit x tends to 0 b value ಯಾರಾದರೂ ಹೇಳ್ತೀರಿ? What will get? B into, this is also a standard limit 1. In the numerator, limit x tends to 0 b is there. Anyway, answer? Which rule you want to apply here? Constant rule. Limit x tends to 0 some constant is equal to k itself. Not 0, x tends to a. ಅದು ನಿಮ್ಮ ಥಿಯರಿ ಒಳಗೆ ಹೆಂಗೆ ಹೇಳಿದೀವಿ ನಾವು. Limit x tends to a some constant is equal to the constant itself here. No change in it. So definitely b remains b only. In the denominator, a remains a only. So a into 1 is a plus b. In denominator also a plus b. So a plus b and a plus b cancels. So the final answer is 1. The next example. See, limit x tends to 0. X tends to 0. Cosec x minus cot x is it. Cosec x minus cot x is there. Question is to evaluate this limit. In two different ways we can follow or we can continue the solution here. This is equal to limit x tends to 0. I would like to write cosec x minus cot x whole divided by 1 I would like to write. Nothing means in the denominator you can write 1, no problem. Recall the identity, trigonometric identity, limit x tends to 0 as it is. Cosec x minus cot x. Anybody, is it possible for you to say, in terms of cosec x and cot x, how can we replace 1? By using trigonometric identities. In particularly 1 plus cot square x is equal to cosec square x. ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ರಿ. 1 equal to ಹೆಂಗೆ ಬರೀತೀರಿ? cosec square x minus cot square x you can write. Now this is equal to limit x tends to 0. Limit x tends to 0. Numerator as it is, cosec x minus cot x. Cosec x minus cot x as it is. But this denominator can be written as a square minus b square form. A plus b into a minus b. Cosec x plus cot x into bracket cosec x minus cot x. A plus b into a minus b. So cosec x minus cot x. This one and this one cancels. 1 upon cosec x plus cot x remains. This is equal to limit x tends to 0, 1 upon cosec x plus cot x remains. See once again, cosec x plus cot x remains in the denominator. That I have written. Then again it is not defined. Still needs to simplify. Limit x tends to 0. 1 upon cosec x can be written as 1 by sin x. Cot x can be written as cos x divided by sin x. Sin x is the LCM. And shift that LCM sin x to the numerator. One step directly I would like to write. Limit x tends to 0. Sin x divided by or otherwise extend one step. 1 upon 1 plus cos x divided by sin x you can write here. Okay. This you can easily understand. Sin x is the LCM here. In the mode of simplification, sin x goes to the numerator. Limit x tends to 0. Sin x divided by 1 plus cos x. Now it is the time to evaluate. Sin 0 you can write in the numerator after substituting 0. 1 plus cos 0 you can write. Cos 0 value is 1. Sin 0 is 0 here. 0 divided by 1 plus 1, which is equal to 0 by 2. 0 by 2 is a finite value here. 1 cos 0 value is 1 here. That's why I have written 1. 0 upon 1 plus 1, 0 by 2, which is equal to 0 here. So 0 is the final answer for this question. See students, the next example. Limit x tends to pi by 2. X tends to pi by 2. Tan 2x divided by x minus pi by 2 is there here. You need to make the substitution x minus pi by 2. This is equal to theta. So as a result of this, x is equal to pi by 2 plus theta you can write. Here in numerator is 2x. You may take directly here. 2x is equal to 2 into pi by 2 is pi only plus 2 theta you can write. Okay. And then tending limit. When x tends to pi by 2, then theta tends to 0. X equal to pi by 2 you need to substitute here. Pi by 2 minus pi by 2 is 0. So theta equal to 0 means theta tends to 0. So this is equal to limit x tends to pi by 2 is to be replaced by theta tends to 0. Tan 2x is there. 2x means pi plus 2 theta divided by this is as a whole theta here. So this is equal to limit theta tends to 0. Tan 180 plus theta. Tan 2 theta itself. Allied angle property, trigonometry you need to apply. Trigonometrical knowledge here. Tan remains tan only. 180 plus 2 theta is in third quadrant. In third quadrant, tan ratio is positive here. Whole divided by theta. So this is equal to limit theta tends to 0. Tan 2 theta divided by 2 theta into 2. 2 an extra term you need to take. So take 2 constant outside. Limit theta tends to 0. Tan 2 theta divided by 2 theta. So this is equal to 2 into, it is a standard limit, it is 1. It is 1 definitely. So this is 2 into 1 is 2 only. So the final answer is 2. So this completes the solution for this 22nd example. Okay. I hope you followed all these examples. Let me continue the remaining examples in this exercise in next class.